Good morning, everyone. I wish everyone a very hot welcome to the first of the series of DC Brain Up webinars. My name is Geert Molenbelt. I'm here today to moderate and introduce the people who will make the presentations and who are glad to accept our invitations. So DCbrain, this webinar series is about green gas quality tracking. And in the application, you will have just a few remarks on the technical side. You will see a chat where you can ask any questions. There are specific section for the detailed questions we will develop alongside this webinar. And there's also a section for polls where we regularly will pose some questions, and the answers will be presented at the end of this webinar. So green gas quality tracking is the topic of today. And I will start with presenting the team of people who will present today. So we can move on to the presentation. And starting will be Laura Bosetti from Eurogas. Laura, please be so kind to briefly introduce yourself.
Hello, Gerd, and thanks for having me. So yeah, I'm Laura Bosetti. I work at Eurogas. I'm a policy advisor, and I mainly focus on retail, taxonomy, and distribution.
Okay, very well. So DCbrain is a member of Eurogas for almost 2 years, I would say. The next one who will present is Arnaud de Moissac, who is CEO at DCbrain. Arnaud, a quick introduction.
Thanks for the introduction, and very happy to be there this morning. So I'm the CEO of DCbrain. We've co-founded with Benjamin DCbrain about 8 years ago, and I'm very glad to have the opportunity this morning to introduce you our product and technology based on hybrid AI and what we've developed at DCbrain to fix the gas propagation issue.
Very well. We look forward to that part section of the presentations. And finally, we have Anne-Florence Castaing from our partner REGAZ in Bordeaux, in France. Anne, could you please briefly introduce yourself?
Hi, Gert. I'm glad to be here today. Okay, thank you for the invitation. So, Anne-Florence Castaing, I am in the Engineering Studies and Innovation Lead Manager at REGAZ-BORDEAUX, and I deal with REGAZ grid distribution network design and development that includes renewable gases project in Bordeaux and surroundings. And as you said, we had the opportunity to collaborate with DCbrain because we needed to track the biogas after its injection on the network.
Okay, very well indeed. And I confirm that REGAZ was the first DSO where we industrialized the gas quality tracking solution, and it's running for over a year right now. So let's move on now to the first speaker of today, which is Laura Bosetti. I would say the floor is yours, Laura.
Thank you. So good morning, everyone, and I hope you can see the slides. Can you? There we go. Okay, great. So good morning, everyone, and once again, thank you for having me and having Eurogas at this amazing event. So I will try to give in 10 minutes very quick picture of the regulatory framework that we have right now at the DSO level. So maybe just a quick introduction. So at Eurogas, we represent the mid-lower part of the value chain. So shippers, retailers, and distributors from all around Europe and not only. So we have the luxury, I think, to have a very comprehensive and global picture of the current regulatory framework. I guess many files keep us busy at this moment, and unfortunately not only files. So I will try to give you a short overview of the regulatory framework that the distributors are dealing with at the moment. So I would maybe divide it in two pillars. So the gas package, the real core of the gas sector, and the thing that will drive the decarbonization process for the sector itself, and the 50 for 55. So both pillars, I think that they can be considered very challenging for DSOs. Unfortunately, it's clear that the European Commission at the moment doesn't aim at having hydrogen at the distribution level. And at the same time, they want to phase out fossil fuel as soon as possible, especially in light of the crisis in Ukraine. I guess everyone read the communication on energy prices from the Commission. So this is extremely clear looking at the gas package, because the whole structure risks, unfortunately, to underestimate the role of the DSOs, especially when it comes to the unbundling rules. So I'm not going into the technicalities given the time, but I guess all of you know that the proposed unbundling rules don't allow it, don't encourage DSO to decarbonize the grids and to convert to hydrogen. So after 2030, in the moment actually you reach more than 97, 98% of hydrogen blending, you will need to sell your assets. Also, if you look in details on the hydrogen side, the proposal talk about hydrogen network operators, so without really differentiating between transmission and distribution. And it's also interesting to notice that the majority of the provisions related to hydrogen network operators are suited more for transmission operators than for distribution. So what we can conclude from this is that this proposal, at least from the distribution side, is not future-proof. So, of course, the reason behind this approach are very clear. As I said before, the Commission approach doesn't really want hydrogen at the heating level, but they don't really consider that at the distribution level, we also have many industrial users, and also they don't consider the role of hydrogen and gaseous solutions in general, that this can have in balancing the grids, first of all, ensure flexibility, and ensure security of supply. That is going to be a very important issue. Is it already right now, and is going to be, I think, in the next month, even more. Some of the issues actually that the Commission raises right now are related to safety of hydrogen at the distribution level, and also on hydrogen leaks. But I would like maybe to come back to these issues a little bit later. So I talked about two pillars. One was the gas package, and the second pillar is the Fit for 55. Once again, is not really a favorable framework for gaseous solutions, at least in heating. So I would say that taxonomy in red set the picture. So in red, so the Renewable Energy Directive, the headline element in the proposal is to raise the binding target for the share of renewables in the energy mix to 40% by 2030. It's worth to notice that we have targets for industry and transport. I think for transport is to reduce the greenhouse gas intensity of transport fuels by 13% by 2030, but we actually don't have targets for heating. And this says a lot. And also in taxonomy, I would say taxonomy is a mixed bag. So I think we need to welcome the fact that the natural gas activities are considered as transitional activities. So finally, gas activities are actually included in the taxonomy. But the criteria are very challenging. So a full switch to low carbon gases is expected by 2035. And as I said, the criteria are very challenging. So for example, the 270 grams CO2 per kilowatt hours direct emissions threshold, for example, for CCGT are difficult to achieve, but maybe slightly more realistic for CHP. This framework puts a lot of pressure on the grids, and especially on the speed that the decarbonization process has to keep. Maybe to go into more detail of the proposals. So, as I said, taxonomy red set the picture, but we also have the EPBD, so the Energy Performance of Building Directive, that sets, let's say, a different kind of picture for buildings, so more in detail. There is a definition of zero-emission building, and this is going to be the purpose for Europe for the next years. In this definition, actually, they say that the energy produced nearby can be accounted for the energy performance of the building only if there is a direct connection, so between the production and the building. At the same time, this directive brings forward the important concept of energy communities. But once again, it refers actually only to natural gas and not to hydrogen. So somehow it excludes it from buildings and from the heating sector. This is also very clear in the eco-design and energy labeling. So maybe this is more, let's say, a technical file, at least for us policy advisors. It actually encouraged the use of hydrogen readiness, the hydrogen ready boilers, and this is very much welcome. But it also sets a PEF, so primary energy factor of 1.65. And this is very counterproductive because it means that hydrogen ready boilers would fall under the lowest energy efficiency class, so it's class G. And this doesn't really encourage consumers from investing in hydrogen. So it will lead also to additional costs where gas DSOs switch to 100% hydrogen. And maybe last but not least, the EED, so the Energy Efficiency Directive. I would maybe highlight only the part on energy savings. So it's a very, let's say, electrification focused directive, and this is fine. We have to focus on renewables, but I think it's very important to enhance the role of gas solution. So the decarbonization potential of gas, and of course I'm talking about renewable and low carbon gases, should be eligible to contribute towards national energy savings obligations. And right now in this proposal is not. And this can actually undermine the overall decarbonization goals. So given this very challenging framework, what should DSOs do? And this is basically the role of Eurogas to understand this. So in the gas package, there is the proposal to create a DSO entity, so an integrated DSO entity. We believe that actually a gas DSO entity would be very important to have. Why? Because it would allow gas DSO to speak as one formal voice, but also to have the mandate to facilitate the cooperation between DSO and TSO across gas and electricity. Also, one important part is the network codes. DSOs want to be involved in proposing new network codes, but also in editing the current one. At the same time, it would allow DSOs to work towards an effective methane emissions reductions. Also, methane emissions is a very important file that maybe I didn't touch upon, but it's actually something that we are also working on, and also to facilitate local production plans. So this is the aim that we want to reach, at least for the gas package. But it's also worth to underline that DSOs are just, they're not just waiting for the regulatory framework to change. They are doing something. And this is very visible, for example, in this amazing study. So this study is called Ready for H2, and I really encourage you all to check it out. It's a new study. It started at the end of last year, and right now it involves more or less DSOs from all around Europe. So, and also associations, so such as Eurogas, SEDEC, GEOD, Marcogas, and so on. So our main goal is to show and to assess the status of DSOs around Europe when it comes to hydrogen. So we want to combine the hydrogen expertise and experiences across all the DSOs to highlight the best practices and to find the best way to decarbonize the energy grids. And once again, we have many deliverables, but we are basically collecting all the experts around Europe from the DSO sector to show how it's feasible and how it's realistic actually for DSOs to contribute to decarbonization. So maybe just to wrap up, DSO have a pivotal role in the decarbonization path. Maybe we can see it in short term and in long term. So on a short term, with gas blending on existing networks, this is a very realistic option. So a gradual increase in renewable gases is likely and it's realistic. Also, it's worthy from maybe the economic side, because we can use existing infrastructure and they can be upgraded to make new networks sustainable without a huge investment needed. On the other hand, maybe on a longer term perspective, DSOs they will be part of the hydrogen network. So maybe coming back to the issues that I raised before about safety and hydrogen leaks, there are actually already excellent digital solutions that can help and detect hydrogen leaks, but also in the decarbonization itself. So it's just a matter of investing in these solutions and, in taking advantage of the many experts that we have, and they're already working on this project. So I really hope that I didn't go too fast and that I gave you a rough idea of what is the framework right now. Once again, what I'm trying to highlight is the big role that DSOs will have in the decarbonization path, and they're already working on it. So I really hope, as a Eurogas, we really hope that the Commission's proposal will recognize it. So thank you, and I'm available for any questions.
Okay, thank you very much, Laura. I do have a personal question, and before asking it, just letting know everyone that you can ask questions in the user interface of the Livestorm application on the right bottom side. There's also a poll you can fill in with questions that will be asked throughout the presentations. So Laura, coming back to your presentation, I see some future solution whereby you change the 1% from 99 to 100%, and you become a full hydrogen or renewable energy network. What will actually happen then? You're not allowed to exist as a DSO anymore? What is the...
So right now, from 2030, as you said, it's 1% that will change a lot. If you switch to 99, 100% hydrogen, either you invest in an ISO or you sell your assets. So basically, a gas distribution, a gas DSO cannot be at the same time a hydrogen DSO. They have to be two different entities. So it means that basically, if I imagine a company, a DSO company, they're not encouraged to switch to hydrogen. I mean, why would they at this point? In the moment you become a hydrogen DSO, you need to sell everything. So this is basically what we're trying to work as an association representing DSOs, and many other associations are trying to work on this.
Okay, and biogas, what is the role in there? If you have biogas and hydrogen and no natural gas, how would that work?
Yeah, no, exactly. So for now, it's really the proposal is very much focused on hydrogen. So this is another very good question, honestly.
Okay, so the conclusion is that there's a lot going on in Brussels, and It's good to have you there talking and persuading a lot of people. And the other message I got is that all the DSOs need to collaborate and work as a team, as Europe is demonstrating as well. And that's also a good thing, I believe. So it's time to move on to the next speaker, which is Arnaud Moissac. And Arnaud is going to present a little bit in more detail the technical aspects of the engines behind the user interfaces. You will see a DCbrain. So there's going to be a short jingle, and then Arnaud will join us.
Okay, my turn. So thanks, Geert, for the introduction. I'm going to present you what we do at DCbrain and how we build a product to help our customer DSO and TSO to face all the complexity and all the challenges they face today. So perhaps in a nutshell, perhaps to bounce on what Laura just said, we all know that we could say that there's three main constraints on the head of the DSO and TSO today. First, it's all about pressure and gas pressure, but regulatory and geopolitical pressure. Regulatory pressure was well described by Laura just before. And about geopolitical, I think I won't go back to the tragedy that occurs in the east of Europe, but we all see the impact on the gas European network. The complexity increase, the increasing of the complexity is also something very strong to manage. And that goes to gas blending, because all the DSO and TSO have to anticipate and to face gas injection, grease gas injection, decentralization, etc., etc. And of course, on top of that, we all have, as an industry, pressure on OPEX and CAPEX, and also on quality of service. And at DCbrain, we strongly believe that the use of a digital twin based on a data-centric methodology can really help DSO and TSO to handle those complexity. Meaning that if you are able to extract data, to fix them, to add constraint and business rules, you will be able to, we could say, enhance the way you will work every day by calculating, simulating, optimizing, viewing, and sharing everything faster and better inside the company and beside the department of your company. Perhaps in a nutshell, how does it work? Well, first you have to get some data to build that digital twin. So the kind of data you need to have will be your GIS, for instance, assets, the measurements. You can also add some external sources, data source, like weather, holidays, what we call time features, and of course some business rules, some constraints, some objectives. Once you have collected some of those data, you don't always need all the data, but at least you need to have the network itself. So really the shape of your network, the assets, and most of the time you also need to have some measurement to for instance, do gas propagation. You will ingest that in the digital twin, the DCbrain digital twin. We are going to consolidate all those data together, and thanks to that, we'll be able to answer some of the main use cases DSO and TSO face today. For instance, we are able to address green gas quality tracking, or consumption forecast, or for instance, prescribe optimal scenarios. All those use cases are already on production with some of our customers. For instance, today we are going to talk about green gas quality tracking, thanks to the digital twin. That's typically what we do with REGAZ today. So perhaps a few words about what we call hybrid AI, hybrid artificial intelligence. the problem we face when we try to work on a digital twin only with, for instance, neural nets or deep learning, is deep learning approach are basically statistical approach. And when it comes to simulate gas propagation or pressure inside gas pipe, we can't afford to have an answer from a digital twin like the pressure will be that pressure with a margin error of 20% because of that statistical approach. It's not acceptable. That's why most of the, or almost all the tools used by the gas operator are based on physical laws, are real solver, because we need to have a very rigorous and precise results when it comes to estimate, for instance, the gas pressure or gas quantity inside the network. The problem with that approach, it is quite slow. It's really complex to set up and to fine-tune. And typically, that's why we decided to build a product that mixes the best of the two worlds, the lightning speed of deep learning with the rigor and the precision of a classical solver. That's why you can find on that screen, on one side deep learning and on the other side delta pressure equation, because thanks to this hybridization, we are deeply anchored in reality with thermodynamic laws. We also exploit the power of deep learning and the power of data, and thanks to that, we are about 100 times to 1,000 times faster than our competitor with the same level of precision. But let's go perhaps deeper in what does it mean really. So I'm going to take a quick use case about gas flow propagation. So I will try to avoid to speak too much about mathematics and physics, but you know, we are all in the gas industry, so we love math and physics, by the way. So typically, that use case, we have an input of gas in the network, so the yellow points. We need to make that gas travel to the network to deliver our customers, so the red points. And basically, what a solver needs to do, a solver needs to calculate or estimate, for instance, the gas pressure or the gas flow in every points or pipe of the network, and in all use case gas quality tracking, we need to be able to estimate at every point of the network and at the end, at the delivery points, the mix between, for instance, biomethane and natural gas. That's typically what we do with REGAZ. So the first approach would be to use a classical solver, but it's far too slow to be efficient regarding the constraint we already talked about. So we are going to mix deep learning estimation and solver approach to be as faster than the other and with the same level of precision. So how is it possible to have a good approach using neural net and deep learning and statistical approach? What we do at DCbrain is we've created what we call gas flow networks. And the idea is to train neural nets. Well, basically, when you train a neural net network, you train that network to make the best approximation between the real results and his prediction and his forecast. And what we do at DCbrain is we use physical law to make our neural nets. Well, what we ask our neural net is to find the closest solution regarding the physical meaning of the solution. So we give him a network and we tell him, okay, and now you have to find the pressure on every point, but not regarding the result we are waiting for, but regarding the respect of physical laws. And thanks to that, we are able to have a very, very good generalization of the result of the neural nets for any kind of gas network. And once we've done that, we re-inject that deep learning, those deep learning results into our solver. Basically, it's more or less to give the ability of the solver to have a kind of superhuman intuition. So, for instance, the solver won't try every kind of solution he classically try to solve. Is going to be helped by the neural nets, by something like, okay, I'm the neural net, you, dear solver, you should start at that point to find the best solution. And when you try to converge and to find the best states for the estimation of the gas mix in the network, you should go that way and not that way, because as a neural net, I'm able to give you the intuition of what a good solution is. And thanks to that, we are able to reduce by 90% the number of iterations needed by the solver to find the solution. And on top of that, we also redevelop all by ourselves a physical solver based on GPU. And thanks to that, we are able to calculate about 1,000 times faster than our competitors. Well, that's it. So if you have questions, because I have only 10 minutes to go deep in that quite complex technique, but I will be very happy to answer a question. And perhaps to summarize, it's not about being faster than the other, it's being fast enough to allow our customers to, for instance, do what we call software sensor. So you don't have to redeploy a sensor everywhere on the network. You can rely on hybrid AI to estimate more or less in real time the quality, the gas quality in your network. That digital twin is really better than the other to readapt itself and to reshape its model to be the closest as possible as reality. And on top of that, thanks to this hybridization compared to deep learning classical products, we don't need that much of data, because as we deeply rely on physical law, we can find by ourselves data and measures everywhere on the network. And I think that's it.
Well, thank you very much, Arnaud. I remind everyone it's possible to ask questions in the special section on the right of your user interface. So, Arnaud, are there any limitations on the size of the network? Because many networks with small injections may be tempted to calculate with traditional ways. How is the scalability of the solution look like?
Well, I would say, of course, the biggest is the network, and the more complex is the solver, and of course, when the network gets bigger and bigger, it will take more time to compute. But considering the fact that we are about 1,000 times faster than a classical solver, if your network is really, really big, at the end, well, only a technology like the technology we use will be able to handle that very huge network.
Okay, very well.
And the solution is built to be what we call, well, it's IT wording, but horizontal scalable. It means that we just have to add some servers beside the other server to increase the computation power.
Okay, and what about the mixture of different gases? If we imagine both biogas and hydrogen, for instance, is that something the application or the model can deal with?
Well, today we have two kind of customer on that. REGAZ mixing biomethane and natural gas. Another customer outside of France who use DCbrain to calculate the mix between hydrogen and natural gas. So for the moment, the use case we have on production are about two gas mixing, but I'm not sure that it would make sense to mix biomethane, natural gas, and hydrogen. But there's no real wall to it won't be an issue for the solver.
Yeah, the question was more on the technical side, and the answer is of course yes on the technical side, but given the pace of implementation of hydrogen, we don't see that many deployments yet. Yeah. So since there are no other questions, I propose we move on to the next speaker, which is Anne-Florence, and let's launch the jingle.
Yes, thank you, Gert. So, hello, everybody. I'm here today to present how REGAZ has collaborated with DCbrain by developing a digital solution for renewable gas tracking, that it has been explained before. Maybe can we switch to the presentation? Okay. So let me introduce REGAZ first. REGAZ is a gas distribution company operating a network of 3,500 kilometers, covering, as you can see on this map, 46 cities around Bordeaux. REGAZ is connected to TEREGA, a high-pressure transport network from 7 gate stations that deliver the natural gas. And so far, we have in operation 4 biomethane injection stations. The first has been installed in 2019 for a total presently of 1,300 cubic meters per hour. That represents roughly 15% of the total gas transport during summer, when the total gas is the lower during the year. So our challenge in REGAZ, and like all other DSO, is to make sure that the biomethane that is injected from and produced in the farming areas can flow toward the urban areas when we concentrate the gas usage, which are the domestic building for heating and cooking, mobility for the gas vehicle, and of course the industry, and what we can say that all of these usage are looking for decarbonation. So what we have to do is to make sure that the biomethane can be used in substitution of the natural gas. And in that goal, we have several options to adapt our networks, because now the gas is flowing differently. First, we have technical improvements that the most common are adding pipe connection and new pressure reduction station. And then we select as far as possible the highest pressure for the level of injection by biomethane. And then, of course, the gas operator can modify the pressure in the different pipes. But we have other solution today, which can call the smart grid solution, and it's technologies that are based with IoT solution. And the Mocabio with DCbrain is one of them, with a digitalized application that I will present you how we have managed to install it, and how now REGAZ is operating with it. So, of course, the objective is to make sure that the gas demand, which is not regular and vary from the demand depending on the season or the daily variation, can be adapted while the biomethane production is steady. And as always, make sure that biomethane keep the priority on the natural gas. On the next slide, okay, here you can see the picture of what the DCbrain solution with MocaBio tool provides. So MocaBio is the tool developed with DCbrain. It combines the grid cartography and the consumer database. So that are two different two things that the gas operator is as for his operation, and they calculate each day from this input data and taken the total flow taken from the maximum rate registered the day before, and then we see how the biomethane flow is spreading through the network and mixed with the natural gas. So it gives a bright picture every day. So we have a daily calculation. And as you can see, we have the red spots that are the injection points, and the blue circles where the biomethane is exceeding 50% in the mix with natural gas. So these parameters can be modified, but as a first approach, it's how we have worked for now almost 2 years. This program helps REGAZ in several ways. And for the MocaBio's result, we can say that first, it is used for consumer billing, since biomethane molecules is identical to natural gas, but as for billing, there is a slight difference. So it gives everywhere, every day, the biomethane ratio at each user point on the whole network. And of course, we can imagine that this calculation maybe also help if we consider the data coming from the real-time gas metering, that we should be finally able to predict everywhere the exact gas ratio at any point. But secondly, MocaBio gives also the gas operator a visual and an easy representation of the biomethane to eventually adapt the parameter. So especially during summertime, we have a low transit all over the network. And if we want to avoid overpressure in pipes and make sure biomethane distributes correctly, then with prediction, we can adapt as fast as we can, because we have predicted information. And then we modify the parameters and pressure parameters on our network. So it helps to make sure that we have a constant biomethane injection and avoid overpressure and let the natural gas coming up instead. Okay, and we can say also that MocaBio is a very nice communication tool with our stakeholders. So we have local city governments, industrial partners. For them, MocaBio provides an informative picture of what is biomethane and how the grid works with it. I would like to show you a small video that we have built from some snapshots that are daily calculated. So if I launch the video, you will see how we can visualize how it works all over the years, and it starts from the first injection in 2019. So like the blue circles, you can see is changing So when it's closed, it's winter time, and during summer, that you can see it's spreading wider and more close to the city. And in 2021, after the first year, you will see that, okay, it's coming soon. When we will have a new injection point from here, so the biometers covering all over the network is getting wider, and it gives a very nice picture of what is physically is going through the pipes in the network all over the REGAZ grid. So one, we can say that from today and in the next coming years, REGAZ should adapt to allow all new sustainable gases in its grid. And for this, and thanks to the smart data, this is a picture of what we can also predict for the future. So now we have with DCbrain the first application for the gas spreading in the network. We have also, based on that, installed a RAF system, which is a remote automated flow, which is an equipment that communicates with the grid, so we can remotely modify the parameters on the reducing station, and so it gives flexibility, and it is physically an equipment itself. But if we look longer in the future, we all know that we will have to develop more and more injection of biomethanes. So there will be a multiplication of these points, and then we will have to have a good understanding every day, anytime, of how the grid is working. Of course, to still have the confirmation that we guarantee the continuity of the supply in the network, but also we have to guarantee the safety. So all these predictable information are a very interesting tool for us to deal with all these renewable gases. And because we are also working in the future, and as Laura has said before, we still are now working of what's next with these green gases, because for by 2050 we have the goal to reach the 100% of green gas in our networks. So it will not only come from the anaerobic digestion of the biomethanes today. We need to focus also on other processes like the power to gas and power to methane, also the gasification processes. And to finish, because we have already talked about that, this is the hydrogen and renewable hydrogen that will come sooner or later, but that will come in our network, so we will have to track it anyway. So we are thinking of these next steps. We are already work on that. And if we, to the conclusion, if we want to make what can be the next step for us with DCbrain, and other subject that we can work on. This is the hydrogen blending, of course, but from the first tool we have on REGAZ-BORDEAUX, we can also imagine that we can move from a static calculation to the dynamic solution. Other questions like the detection of anomalies, like the network losses, because either hydrogen or methane losses are a real subject today, and this is to finish with. Okay, so another project that we have today is how to optimize the routes for the safety control vehicles. If we talk about losses, we need to track on a regular basis the safety of the network. So if we can, with a digitalized solution, optimize the route of the vehicles in order to save time, and based on an automated planning, and then we will reduce the cost and the CO2 footprint. So it's just to show that the smart grid solutions, it's not only the green, it's for our work in general. There are plenty of options that we will have to develop in the future. Well, so that was the presentation of the first application and the practical point of view of a DSO. So and it has been installed on REGAZ. I hope it was clear enough, and I would just say that thank you for listening, and don't hesitate if you have any question.
Well, thank you very much, Anne-Florence. It's always very nice to see the practical implementations of solutions alongside the very global view of Laura and the more technical view of Arnaud. I would have a question for you. There's no regulator in France that tells you you need today at least to track the quality of the gas. Could you explain us why you started this this exercise, or what was the kind of trigger for you to start this? And do you have a view? That would be the second question. How the French regulator is looking at this for the future? What kind of regulation could we expect on a local country level on this?
Well, this is important for us to be aware of how the network is operating. It's a question of safety, and this is our role to operate the network with the gas, and we need to with this guarantee. We strongly believe that we have to know what is flowing at any time to make sure the security of the assets is okay. So tomorrow we are looking for the 100% green gas. If maybe we will have hydrogen blending upstream or downstream, but it's important for us to get input data for maximum input data for prediction, and then operating and monitoring that, because it will help a lot.
Yes, I think that's one of the other important lesson that we learn. It's just not only a digital solution that will help you, it's also how you can implement the results on the ground, and that's really impressive what you have done at REGAZ with the remote monitoring control systems. Well, thank you very much, Anne-Florence. I think it's time, and we have the opportunity now with the recent technologies to have a kind of joint question and answer session, and I will use as a guideline for that the polls that you have been so kind to to fill in. There's still a little bit time left, but I'll go over question by question. And the first one is the priority in terms of type of gases, and we see a very clear majority. It's not only about biogas, it's biogas and hydrogen that almost everyone, 2/3 at least, filled in. There's only one which has answered no green gases, so that sets a little bit the stage. A short question to you, Anne-Florence. You mentioned 100% green network. When do you expect that to happen for REGAZ, and is the road to carbon neutrality very clear?
So the ramp up is not very quick, but we have in our region, Nouvelle-Aquitaine, a plan so we can be able to reach that goal. So we have taken from expertising local resources, and we have figured out that in that area, Bordeaux and Nouvelle-Aquitaine, we have enough resources to create green gas. It's as well as for anaerobic digestion, but also the new processes like gasification systems. So at least what we have in mind is that we will take all the resources that can be converted to gas, but not entering in competition of the actual using of this. I mean, we want to develop farming product for energy. It's just like what cannot be used for all the farming alimentation, we will use it for energy. So there is no competition between the resources, but our area of Nouvelle-Aquitaine for sure will be even exporting gas energy by 2015. Yes.
Okay, so your goal is 2050 in line with the European regulations.
Yes, but
some intermediate objectives in the company.
Oh yes, we have intermediate, but that's the national goals that we are following. So biomethane today we have in the same average quantity of injection in the network as the other parts of in France. So, and we have even exceeding like the first stepping, which is by 2030, that we are in a good way to have the rates that are in our mind. So no, it's I won't say that we go very fast because it is all our long time projects, but there is a very strong motivation with different all the industries that are focusing on these activities. So we are pretty confident that we will be able to reach that goal.
That's very good news. Indeed, there have been some questions coming in, so I'll take the opportunity to do that in a live mode. There's Maxime. Does DCbrain's solution can provide dynamic simulations? And that's a question for Arnaud.
Well, yes, we can and we do. It's also a matter of data availability and time frame resolution, but yes.
Okay, that's what I thought already, and maybe a little bit more questions for the others as well. Fernando from Portugal, assuming that we get estimates or results, could we think of having some kind of certification that could make the solution homologable for fiscal measurements? And that's, I think, a very interesting question. between the fact that we have digital outcomes which are based on data and that need to be aligned with physical physics in the network and measurements. Does anyone else, Laura, maybe something to say about certification of gas blending?
So if I understand correctly, how certifications can be translated, maybe in the billing, and how this can be translated in a contract, for example? Is it? Yeah, certifications for sure are a possibility, and it's something that the Commission is working on. I think it's a process, but it's definitely a possibility. I actually recently assisted to a presentation on how this can be translated in, something that the consumers can see on a billing. But definitely, it's a point, and it's important because, of course, what you blend, it's definitely something that eventually the consumers has to see.
Yeah, I think it's a very good, interesting question, and hard to answer. What I can tell on the side of DCbrain is the following: that we've done some exercises on putting chromatographs and checking the forecast model, the gas quality model, against the measurements of a chromatograph, and we got over 90% correct inputs from that. So that's a very strong argument to rely on digital solutions. But the next step to make it an official certification is of course something that needs to be dealt with the regulator together, and frameworks for doing so is definitely something that needs to be worked on, I would say. There's another question from Gise, that's maybe Jean-Christophe, or probably, I don't know. Did you explore how your solution can support companies for their green carbon neutral initiatives throughout the whole supply chain, and how gas players can help entities, steel, cement, etc., meet their net zero commitments? That's also very interesting questions, and there's a political angle, there's a technical angle to it. Maybe just first the technical angle, Arnaud. Could we imagine that beyond simulation and gas work, we could broaden the scope? I know DCbrain does a lot on supply chains as well, in terms of modeling, digital modeling. Are we confined to just the gas pipe, or can we do more than that?
Well, the problem is not exactly the same in supply chain and gas, meaning that for supply chain industry, it's really important to be able to really calculate the amount of CO2 emitted, for instance, by a parcel or by a pallet or by a truck, while for the gas industry or for the energy industry, most of the time we rely on carbon neutral certificates, and we don't really expect the customer to really count the number of molecules of green molecules and not green molecules they consume. So technically, we know how to tell a customer, and that's exactly what we do with REGAZ. We explain with others the percentage of green gas and natural gas a customer will consume. But I'm not sure it will answer the question on getting greener for a company.
Let's ask the question to a DSO directly then, Anne-Florence. Are you involved in any activities with major industrial customers to help them migrate to carbon neutrality?
But yes, there is the demand. So we need to differentiate the molecules that you get at your user points. But the industry can also asking the guarantee of the gas they are buying. So that are two different things. So what we do with DCbrain when we are looking for the gas spreading in a network, it's like physically the molecules which is injected in the network is going in different points, and there is a mix of ratio with natural gas. But then if we have an industrial that who is looking for a guarantee that he is consuming a gas with no impact on the climate, so is able to ask to the gas supplier and to have a special guarantee of origin, and so he can justify that all the activities he has with using gas is neutral with in carbon. So
Okay.
for example, if we have vehicles, so you can buy a biogas contract, and then you make sure that the gas that you are buying is
100%.
zero emission. Yes, zero emission. After that, physically, it's maybe not, but it's a great balance between all the origin of the guarantee of the gas that is produced every day in France on the national territory. So there is this kind of trading, and then you can have so you difference at what you physically is using on your using point, and what you are buying, and what you can justify then for your carbon
That's
emission.
clear. Maybe Laura, could you add maybe on the European level, what is your feedback on initiatives to decarbonize heavy industries like cement or steel? And maybe you have something to say as well on certificates of origin at the same time.
Yeah, exactly. So honestly, I think they already said everything, but the guarantees of origin is a huge topic, and definitely a hot topic right now. But the aim of the regulators right now is to really empower the consumers to know and to choose what to consume. So guarantees of origin is definitely a good tool to do this. And on your second question on industry, definitely hydrogen is something, especially for steel, that the Commission is considering. And as far as I know, it has proved to be definitely an efficient tool to decarbonize.
Yeah, I believe the first major productions are going onto steam next year, I believe, for the steel industry. Okay, because the time is a little bit running out, let me go back a little bit to the polls, and if we don't have time to answer all your questions, we will answer them through the follow-up email. Just quickly on the impacts on green gas in terms of regulations, it's taxonomy in Fit for 5 that set the stage, and I think that's not a surprise. I won't ask you to comment on that. And political situation, obviously. Maybe a question though. We learned this morning that there will be a gradual phase out of Russian gas over the next 4 to 5 years, I believe. And that's an easy question to answer for DSO in Portugal, much more difficult in Germany. What is your opinion on and your feeling if politically some decision or an urgent decision is made to stop Russian gas flowing into the networks? I believe that is a relevant topic. A brief comment on that, Laura and Anne-Florence in particular.
Yeah, so exactly what you said. I think first of all, it sets a different orders of priority, because I think right now the priority was the 5455, while right now is the gas package, and also it moves the focus on storage. and on how to diversify the energy mix. Of course, for some member states, it's an issue. You mentioned Germany, but also Italy. We rely a lot on Russian gas. So we need to diversify our energy mix and also to, let's say, rethink how to use the storage and how to fill them before the winter. The proposal from the Commission is very clear. I think it would be interesting to see how they want to, put it in practice.
Okay, just a quick question for Arnaud. Imagine that you take hydrogen storage as an input in the digital twin. Do you think that could be complementary to the propagation of the flows inside the network by optimizing a combination of both storage, transport, and distribution?
I would say yes. I would say that the biggest change would be regarding the digital twin, I think, to really implement all the distribution and consumption points in the network, because as you already said, DCbrain is also very active on the supply chain area, and we see from our customer that they are all starting to replace their their fuel trucks by electrical and hydrogen trucks. Well, electrical as first, but then hydrogen. It means that we will have to deploy hydrogen station everywhere on the network, and it will have a real impact on the DSO topology, network topology, and of course on the TSO too. So I think the most interesting, technically, the most interesting part will be to be able to take in account those new way to distribute hydrogen, and because of that, to rethink the place for
impact on the
the impact. Sorry, on storage and on network, etc.
Okay, let's move on to the polls. Did you already launch digitalization initiatives? 3/4 replied yes, either with an internal or an external provider, but still 25% not yet. Any comments from Anne? You have been a player probably earlier than the others.
Yeah, of course, digitalization solutions are very nice because we are living a new revolution in the gas and energy delivery, even for the gas distribution. Of course, all is changing because the origin of gas is different. We will, as Laura said, we'll have to make a mix of different gases. All of this is becoming more complex, and the digitalizing solution, even for characterize or to operate or monitor our network, are becoming very important. Let's say we've done that manually for 50 years. Now it's becoming brand new, and all of these solutions are a really good tool for us, and it let us improve our work and the guarantee of what we are doing, and it makes better the efficiency of our operation. So I strongly recommend that.
That's a very nice conclusion, I would say. Looking also at the clock, we are about to end this first Brain Up webinar from DCbrain. I would really like to thank you very, very much, Laura, Anne-Florence, and Arnaud, to have participated. It was not only you, it's also Cassandra Castaing, Laetitia Bocquet, and last but not least, Benjamin from Sensitive Agency, who is behind the screens, putting everything nicely together. So thank you very much, everyone, for participating. We will ensure that there's follow-up on the presentations, on the polls, so you get up to date. It was a pleasure and honor to be with you today, and see you soon at the next event. Bye-bye.
Bye.